All right, everybody, welcome back to C++ for Java programmers. A couple of announcements as we get started. First, I'm going to be live streaming the video for this class on Wednesdays at 3:30 p.m. You are welcome to come and join us. It's a chance to watch the video. You can ask questions in chat. The class meets once a week. If you're having trouble with putting it off and procrastinating, I was totally there. This might be just what you need to keep on track and make sure you keep up with watching the video and then doing the homework after that. The homework will typically come out 1 to 2 days after our lecture videos, Thursday or Friday. My goal is Thursday. Office hours. I needed to move my office hours to 1 p.m. Sorry about that, but it was conflicting with my son's video game time, and he needed the microphone, and it was just a disaster trying to have office hours while he was talking in the background to his friends. So he gets done with school at 2. We're moving that earlier. I'm available at 2. If you guys need to make an appointment, just let me know and I can be there. But there will be noise. All right. If you've not already signed up for Piazza, there's maybe 30 people out of the class who haven't done that yet. Please go ahead and do so. It's a great resource to ask questions, get some help. Heads up, homework 1A and 1B are both due tomorrow night. There was a 1-week extension on 1A because I forgot to put the link up. I apologize for that. And homework 2 will be released sometime Friday morning. I'm writing a brand new assignment for this class. It's based on one we did in the data programming class I taught. We're going to be making a Pokemon battle simulator. So anyway, that's going to take me a little bit more time than normal. So I'm thinking Friday morning for the release date. Next week, I'm gone Thursday and Friday, so the homework will not be due until well after that, sometime the following week. All right, and I took a look at the news. If you are anywhere outside of Madison, you're either getting swamped with rain, 2 feet in Alabama, or the world is burning up around you. So hope everyone out there is being safe and staying somewhere safe. So as we get started today, I'm going to be doing a lot of live demonstrations where I'm writing code and then running it. Over here on our Canvas page, if we scroll down to today's lecture, we're going to be talking about some of the basics and what makes C++ actually different from Java. The little details that we can take advantage of to make our code more efficient to write and run faster, those kinds of things. And then we'll be taking a look at I/O manipulators. How do we make C++ display the text that we want exactly as we want it? And then if I do a good job, I won't have time for primitives. If I rush, I might get started on those. We'll see. But anyway, as I develop the code, I'm going to go ahead and generate a template as I go along. That will be listed on the list of resources, along with the readings and the YouTube link. That'll be here as soon as I get all of this stuff finished. All right, so I jumped over onto a CSL machine. I've got Vim open, and I've started filling out my template. So I've got IOStream, IOManip, and string all included. I've got my using namespace standard, that magic line we will put in every program, and I've got main here. The first topic I'm going to start going through is just variable declaration. I want to do some neat ideas here. So first up, if I just declare a variable, I have to give it the type followed by the name of the variable. We talked a little bit about naming variables last time. In this case, I just want to highlight. The reason I'm doing this is that there is no default no default initialization. X equals, I'm going to end that. I'm going to print out X, end line. All right, so what we'll find out is that there is a value here. It's likely to be 0, but not guaranteed, and we're going to find out. If it's not 0, I want to show you that. I'll come up with a better example to demo this. All right, the next thing I want to do, I'm going to hit escape a couple times. I just want to show you how to compile from the command line. So I'm going to type colon, not the command line, from Vim. So this gives me the ability to execute a shell system command, a shell command. So I can just type the compiler command here. So it's just colon exclamation mark. And then I can give this a name, -o. Let's call this lecture 3. And then I need to give it the name of the file. Let's see. I named it lecture03.cpp. And we'll turn on all the warnings. All right. So if I run this, it's going to hop over to the command, the shell, run this, and then type enter or command to continue. I'm going to hit enter. I forgot to write the file. That's what it was telling me. So let's try that again. Now I can go back, compile it. X is used uninitialized. Cool. It did give me a warning. That's what I want to demonstrate. So the next thing I'm going to do, I'm going to actually run this. So colon, exclamation mark, and then I named it lecture 3. Lecture 03 should run. And here it is. It says no default initialization, x is equal to 0. Okay, that's likely because when the system started up, when I logged into the machine, it had cleared all the memory to 0 because it doesn't want me to have access to whoever was using the computer before me. And this is a CSL machine, so I'm not surprised that that's turned on. I'm going to come up with an example where I can demonstrate that this, in fact, does not always give me 0. All right, so I got an example that this is going to work for. So here's the idea. I'm declaring a string s. It says this string is going to influence the value of x after it goes out of scope. I've got the braces right here. These two braces are going to define a scope block where the string s is only going to be defined within this within these braces. As soon as this closing brace is reached, C++ recognizes that it no longer needs this string. It goes out of scope, and it reclaims that memory off the stack. Then when I declare the variable x, it's going to use that same memory location, and whatever values with, the numerical codes for ASCII values for this string, they're going to still be in memory. And so what we're going to get is approximately 4 characters worth mashed together to come up with an integer. And then it's going to print that out. So here I'm ready to compile. Down there, I'm just going to push enter. Should go back here. It's still giving me that warning that I'm using it uninitialized. And then I'm going to go back and run that right there. And now I can see that there is no default initialization. In fact, I've got 21,865 before I've initialized it. All right, so let me go back over here. What I really need to do, and I've got some choices here, is give this a value. So I can just say x equals 5. And then we can print this line out again. Let's go ahead and write after initialization, x is equal to that. Now I can write, I can compile, and we can run it. Yep, there we go. After initialization, x is now equal to 5. And it is telling me the warning still, it may be used uninitialized, and I'm still using it uninitialized. I left that piece there. All right, I can also combine variable declaration and initialization in the same line. So we can have y is equal to, 4. So here I'm declaring the variable and y, and here I'm giving it a value, so that's initialization, all at the same time. So, and then we can just print this out to verify that this works. I'm going to keep this a little shorter. Y equals y end line. We'll write this. We will compile and we'll run it. There we go. Y is equal to 4. I'll clean this up a little bit before I pass it the final version on Canvas. So it looks good, but for now I'm just going to keep going. Something else that C++ will let me do is declare multiple variables of the same type in the same line. So I can say int a, b, c, and declare 3 variables there. Still needs to end with the semicolon. I can also give some of these values. So I can say int d equals 1, e equals 2, f equal, I can just leave this one undefined, g equals 6, end with a semicolon. All right, let me write some code to print these out, and I'll show you what it looks like. All right, just so you can see what's going on, I've written some code here. It's going to print out a equals, and then a, b equals, and then b, and just go through and do all of them. So I've already compiled it. When I change the focus back and run this, I can see it gave me a whole bunch of warnings for all of the uninitialized variables when I compiled it. And then when I ran this, I've got a is equal to some uninitialized number here, something huge. B is equal to another uninitialized number. C is uninitialized. So just a random number. And then I've got the 1, 2, and the 6 for D, E, and G. Those I did initialize. All right, so initializing more than one variable all in one line totally works. All right, next up, I want to spend a little bit of time talking about how C++ works with Boolean values, true and false, as well as Boolean statements. So over here, I put a comment switch around this because I want to use the variable b to stand for Boolean, true or false values in a little bit, and this will mess it up. So I'm just going to have one block at a time active. So as you guys go through the code, I will leave the first one active on the when you can download the final version of this on the website, and the rest will be inactive. But you'll probably get compiler errors if you have more than one active at a time. All right, so what I want to do now is just see out and print to the screen true equals, and then we'll give this a true and an end line. And we'll do the same thing for false. All right, I'm going to write this, and then I made a little upgrade. So I'm going to hit colon, exclamation mark, and then the up arrow. So what I've done is just merged all of these statements into one line. So I'm going to clear the screen. Then the double ampersand here says, and this is a shell command. It says if the first command is successful, then go ahead and execute the next one. Otherwise, it'll print that error message. So then it'll run the compiler. And if that is successful, then it will actually run the code lecture 3. So this is all going to happen in one line now. If you need to pause the video, copy that down. It's really useful. And I'm just going to run it. So it cleared the screen. It compiled without any errors whatsoever. And now it's running the code. So I can see here I've got Boolean statements. True is equal to 1 and false is equal to 0. So this is how C++ is going to deal with all Boolean values. Anytime I declare a variable as either true or false as a Boolean, it's going to just take that value and store it as 1 or 0 on the inside. What I want to do next is go through and actually use a Boolean value in a conditional statement. So we'll just start out here with creating a Boolean variable b. We'll just set it equals to true, and we'll change that in a sec. And then we'll just print this out in a Boolean statement. So if statements require a Boolean condition, so do while statements, and the middle statement in a for loop. So if b, then we will print out true with an end line after that. And else, we will print out false with an end line right there like that. All right, so this is very bad programming practice. I've got a whole bunch of stuff all in one line. I'll go ahead and tweak this a little bit. It looks better like this, right? But I'm going to have a lot of these statements that all have this exact same structure. So I'm going to put them all in one line so we can see the changes. Let me just do it like this for right now. So for right now, we'll write this, then we'll go ahead and compile this, run it, and just see what's printed out. It should print true. Oh, am I not printing the right thing? Hold on one sec. I forgot the quotes. I was going to print out the words true. All right, time out. Let me fix this. There, that's what I really wanted. All right, write this, clear and run. There we go. Now it's printing true. Okay, I want to go ahead and run this with a whole bunch of different things in the condition statement. C++ accepts lots of different things, lots of different kinds of data, and we'll evaluate them as either true or false. So it's going to simplify an expression in here. It knows it needs to get to true or false, and it takes lots of different kinds of things. So let me just pause the video for a second and write this up so it looks good, where we can try lots of examples. All right, so I've got my Boolean value. I'm just going to print out what it is. To clean this up a little bit, I'm going to put all of these things on the same line. So if b, it does this statement. Else, it does this statement right here. And then I'm just going to copy this line, paste it a bunch of times, and we'll try some different things in here. So we will try so the b is true here. That's my Boolean variable. We will stick in a true, and then over here, this will become true. That should definitely work. Shouldn't be surprised to anyone. False. This is just a way to make sure I don't have typos elsewhere. We'll stick in false. All right, we're also going to find that I can use 1 as the condition. So I can just put in the number 1 right there. I can put in the number 0 because C++ will treat 0 and 1 as false and true. Let me just go ahead and run this much right here. Make sure before I get too far and don't have any typos. Right, clear, compile, and run. So yeah, so b is my Boolean variable. I set it to true, so true. True is true, false is false, 1 is true, 0 is false. But we can do a bunch of other things too. So for example, let's go ahead, we've got 0 right there. We'll go ahead and stick in 42. Much larger number. Let's try a negative number, -1. -1 right there. And how do you guys feel about the letter A? Yeah, let's give that a try. So I'm going to write that. So now for all of these, if this condition evaluates to true, it'll print true. Otherwise, it'll print false. So if A evaluates to true, it'll print true. I'm kind of excited to see what happens. So we'll write this, and then we will clear, compile, and run. So in this case here, 1 was true, 0 is false. That's sort of the standard. 42 is true. And in fact, everything that is not 0 will evaluate to true. So -1 here evaluates to true. A evaluates to true. When we use a character like this, it's going to take the ASCII code. And the ASCII code for lowercase a is something like, gosh, I don't remember. Hold on. Manual ASCII. Here we go. Lowercase a is 97. It's right here. 97. Okay. So when we put a 97 right in here, it's not 0, it evaluates to true. All right, now back here. And of course, just for completeness, I feel like I need to put in at least a couple of these. The relational operators all work. So if I have 3 less than 4, and then over here I can put in 3 less than 4, this should print true because 3 is less than 4. We'll just do a couple of these. If 3 exactly equals 4, then it should print out false. Let's see, how about not equals? Not equals 3 not equals 4, 3 not equals 4. All right, that should be enough. The other relational operators, just for clarity, are less than, greater than. Here, let's do exactly equal to, not equal to, less than, greater than, less than or equal, and greater than or equal to. So those are our choices. All right, cool. Let me just run this, and we'll save that, and then we will clear, compile, and run. Switch the focus back, and we see that 3 less than 4 is true, 3 exactly equal to 4 is false, 3 not equal to 4 is true. Okay, I didn't expect any surprises there. Last thing I want to demo, though, is the logical operators, the Boolean operators. So let me go ahead and write up some stuff. I'll type this up, and then we can continue. All right, just a quick demonstration of the 3 logical operators that we have in C++. True and true. So in this case, let me highlight that. The double ampersand is our AND operator. So true and true should print true. True or false. So the double vertical pipe, it's above the backslash, shift backslash on my keyboard, is the OR operator. So if either the left-hand side or the right-hand side are true, it'll be true. Only false when both of these are false. I suppose for the AND operator, I wasn't very clear. They both must be true. Both sides of the AND operator must be true for that operator to generate a true result. And then the NOT operator is the exclamation mark. So if something is not true, it just switches it. If it's true, it switches to false. If it's false, not false is equal to true. So I'm going to go ahead and write this and run this. Okay, so it clears, compiles, and then it's adding all of these new statements. So true and true comes out to be true. True or false is going to be true because this side is true. And not true is equal to false. All right, I'm going to come back. These are all short-circuited, and I want to talk about it a little bit, and I'm going to use the assignment to demonstrate this. So let me talk about the assignment operator inside a Boolean statement. So one of the things I can do is, we'll just create a variable real quick. Inside of a Boolean statement, I can say something like if x equals 5, that's going to assign the value of 5. X equals 5. There we go. That's going to equal, and then I've got an extra character. That looks pretty good. Let me just see if that compiles and runs. All right, nope, I've got an extra I in there. I see out right there. Okay. Where did that pop in? Right there. X. Write that. Compile and run. Okay. Now I have another mistake. Looks like I lost the word if. All right. Now does it look good? See out that stuff. If x equals 5, so this is assignment, see out true. Yeah, okay. Now it's working. Okay, cool. Check this out. It actually gives me a warning, and they're going to suggest the use of parentheses around an assignment statement in a Boolean statement, a Boolean condition. So right there, I will go back and put those in. I just wanted to show you that warning. This is generally not great practice because it's deceptive. This is a really common mistake to just put in 1 equals when I really meant 2. But what it does when I have an assignment, x equals 5, it's going to take this much of it, and this is going to return the value 5 every time there's an assignment. And 5 is a positive, it's a non-zero number, so it's going to evaluate to true. So let me go ahead and show you what I mean. In order to use this and signal other programmers that I'm using assignment inside a Boolean statement, I'm going to use the double parentheses. All right? And this assignment operator, if I have two variables, int x and y, I can use chaining. I can say x equals y equals, I don't know, 6, 4, I missed 4. What that's going to do is it's going to say y is equal to 4. This much will return 4. So it's going to simplify the right-hand side of this, and then it'll say x equals 4. So remember, all the programs do is it's going to take the right-hand side and simplify, simplify, simplify until I can get to something that I can store in a variable. All right, let me run this one more time. The only way I can make this ever turn out to be false is if I put in 0 here. X is equal to 0. So replace that with, not that one, replace with 0. And we'll write this and run it again. And now x equals 0, that statement will be false. All right, so next up, I want to do a quick demonstration of short circuiting. So I'm over here. I'm going to just say that I'm going to use the variables x and y that I have right there. In this line, I'm assigning them both the value of 4. And what I'm going to do is if, and we'll do false, and then we'll use an assignment operator, x equals 45. Then we will, okay, we'll just copy this line for now. That was the wrong button. We'll put that here. But then what I want to do is also print out x equals, quote, x equals, we'll print the value of x, and we'll just see if x is reassigned. So it starts out 4, and if this is executed, this will change the value of x to 45. So I'm going to write this and run it. Oops, I'm missing the parentheses. Okay, there we go. Now it's working. So it evaluates to false. Maybe I'll put a new line in so that it, and maybe like a header or something to indicate this section, what's going on here. And then I've got x equals 4. So it did not change the value. And what happened is I have an AND operator. And every time C++ sees an AND operator, it starts with the left side, tries to evaluate this. If it's false, it knows that it cannot possibly be a true statement, and it never has to do this side of things. This is a great way to do something known as guarding. If I need to do something like divide by 0 or something like that, I can put that check in right here and then put my dangerous divide by 0 statement on the other side. All right. I'm going to just copy these two lines, paste them again, and set this up with the OR version. So if true or x equals 45, then it'll print out true or false, and then I can print out x again. So write this, run the code. So in this case, my OR statement evaluates to true because it's true or something, but it never goes back and evaluates the second part. This is still equal to 4. Let's go take a look at that code again. So if true or whatever, it doesn't matter what this is, it already knows that it's true. So C++ does not do any extra work whatsoever. This is how it becomes as fast as possible, short circuits this, and never executes this code right here. So be a little careful using assignment statements in conditional statements, whether it's an if, a for, or a while loop. All right, next up, I want to talk a little bit about for loops. I think everyone in the class is familiar with for loops from either Python or Java, but C++ has a couple nuances, things we can take advantage of to do some really powerful things. So I just want to go over all of the little details that make them different. So first up, my standard syntax for loop, I need the keyword for. I have 3 pieces inside the parentheses, and then the body of the loop. Here I've got it enclosed in curly braces. This initialization here is going to be where I'm going to declare a variable or more than one variable. I only get one statement here. So it needs to be if I want to declare more than one variable, a compound statement, and all those variables need to be of the same type. Then I have a condition. Whatever's here that is exactly one statement that must evaluate to something that C++ considers to either be true or false. And there's a lot of things it considers to be true or false. So we can use actual words, true or false. I've got a typo here. The T needs to be lowercase. My other class is Python, where true and false are capitalized, and I'm going to make this mistake a bunch. Sorry about that. I'll get it fixed. It can take either 0 or non-zero numbers for false or true. We can use any of the relational operators, the Boolean operators that I just demoed, and even an assignment statement. We can use text in here because text evaluates to a number, and that's either 0 or non-zero. All right. Now in the increment here, this piece right here can take many statements. They're just going to be comma-separated list of statements. Normally our statements end with semicolons. This is the one condition that I know of where we can use a comma-separated list of statements. And including the ternary operator, so I can actually put more or less an if statement that assigns something to a variable inside the increment block here. Inside the body of the loop, all of the variables I've initialized here and declared are accessible in this scope. When we reach this end of the curly brace and we're outside of the loop, those variables are no longer in scope, they're not accessible, and they will go away. I'll come back and do a demonstration of break, continue, and go to in a moment, and then an iterator for loop after that. Let me go ahead and just do a live demo of how this works. All right, so I'm back in the CSL machine. I'm just going to go with a little bit of code here. Let me type this up and then we'll walk through it. It's just going to be a simple countdown function like a rocket blasting off. So 1 sec. All right, I didn't want to go too crazy. I can do a lot of things with this structure though. So in this case, I'm just going to be printing out basically a square chart. I'm going to go over these IO manipulators in the very next section, but right now it's just going to create a block of a text 3 characters wide. I'm going to right align it, and I'm going to stick the letter N in that block. Create another block 6 characters wide, push this text into that, and then new line. And then in my loop here, so I've got a for loop, I'm declaring a variable I, setting it equal to 0, using the comma operator there to declare another integer, and this must be an integer, and we'll set that one equal to 0 also. I don't have to initialize these, that's optional. And then while I is less than 10, it's going to continue to do this loop, and then during this increment stage, we'll increment I using I++. This is the post increment operator. Habit dictates that I type it like this. The ++I operator is a little faster. There's a Piazza post on that if you're interested. And then also in this block, we're going to do the computation of the squares. We'll just upgrade the square to I times I, and then we'll print this out. Again, we're creating fields with certain widths. We'll print out I, and then another field, and we'll print out the square of it. So let me go ahead and write this and run it. So I still have my countdown, but starting here, I've got the field with width 3, and then all of the I values, and then my field with 6 with n squared, and 0, 1, 4, 9. So it looks like it's working. It's just I'm trying to demonstrate the power of these for loops where I can have many things. I can do almost everything in the same statement. And in fact, these guys are all optional too. So if I want to, I can type for, I can leave this blank. I do have to put the semicolon in, and that's my initialization. I don't need to initialize anything. I don't even need to have a condition. So I can just put in another semicolon right there. That would be that semicolon is the second one. Leave that blank. And then I don't need a increment step either. That's optional. So any of those can be left out. And then I can have any number of statements inside the body of this loop. This will give me an infinite loop. It will never stop. It doesn't initialize anything. There's no condition to check. It just always evaluates true. So let me go ahead and save this and run it. All right, before I run it, I added one more detail. It's just going to print out the word ha a bunch of times. So we'll write this, we'll run this, and there it is. Hopefully that's not making you feel dizzy. I'm going to push Control C to kill this, and then pushing Control C a second time would kill Vim. I don't want to do that. I just interrupted it. I just want to push Enter to go back to Vim. So Control C on a CSL machine stands for kill, not copy. All right, next up I want to just talk about the break, continue, and go to. These are used to escape out of loops. So for my example, I'm going to go ahead and just take a look at this square table. I'm going to copy that. We'll paste it right here. Suppose I don't need to print out all of the really big squares. What if I want to just say if square is greater than, let's see, this went up to like 81. Let's just do the first 50. Let's do area is greater than 50. Then we're going to go ahead and just type break. So what this will do is we'll completely exit out of the loop and just move on. It's going to jump all the way down to the end of this loop. Delete that. And not run any of the rest of the code. Completely quitting. All right, so colon up, compile, run. So we can just look at the bottom loop. I should have put some spaces in. So it's only done the first 7 up to 49. The original one had 64 and 81 also. So it stopped the execution of the loop right there and has not gone back. So next thing up, this is just going to jump out of the loop, completely ending. We're done. Doesn't execute the rest of it. I'm going to go ahead and do the same thing, but use continue instead. Let's suppose we only wanted the even numbered squares of even numbers. So in that case, if square mod 2, let's see, square mod 2, this will give me either a 0 or a 1. If it's an even number, it'll give me a 0. That will evaluate to false. Yeah, that's good. Let's do that. Instead, we'll continue then. So this is, if it's 1, it should be good. That'll evaluate true, so it'll do 1. 2 will be bad because it's going to, 2 mod 2 will be 0, so it's going to skip this one. If it's 3, that will evaluate to 1, so it should continue. So we should get 1, 3, 5, 7, and 9 when we do this. So we'll write that. We'll run this. All right, so this bottom one, why did I get that wrong? Now, guys, I'm just being dumb. It is 4:43 in the morning, so forgive me. I'm just a little tired. Here's what's really going on. I think I just said it wrong the first time, and then got it in my brain what it should be printing, and it didn't match. So if square mod 2, if we have, for example, a 1, then when I take modulus 2, that'll be true. And then we're going to continue. So we're going to skip if it's odd. So that's why it's printing the even numbers. If it's an even number like 2, so I'll take square mod 2, that'll be a 0, that'll be false. We do not continue, and we execute this line instead. I maybe would have been a little better at like not tricking myself if I had done something like this. If maybe throwing the else in there. I don't know. The other thing that I tricked myself with was I wasn't actually using I was using square. All right, so let's try this again like this. And just make sure that it's actually, now it's, yep, so this would have generated false, so it did not continue, and that's why it's printing. So 0, 2, 4, 6, 8. All right, that makes sense to me now. All right, for the next example, I want to go back and grab my countdown blast off. So grab that up here, we'll push it under here. So we're going to be looking at the go-to statement now. Go-to, a lot of people don't like it. Personally, I really don't have a problem with it. So here's the idea. Here's what we're going to do. So inside this loop here, we're printing out all the i's. And then, so 6, 5, 4, 3, 2. We're going to go with if I exactly equals 3, then we'll go to abort. And I like all caps for my labels. So this is just going to jump to this label. So we need to put the label in. When we use a label, we just type the name and give it a colon, and that makes this a label. So go to abort is going to jump down to here, and then I can do whatever I want. I can type launch aborted. We'll throw some exclamation marks. That's a big deal. And then that. So what this is going to do now, it's going to go through, and it gets to 3, it's going to go to abort, goes here, and then prints out launch aborted. It'll never reach blast off. It shouldn't print out 2 or 1. So let's test it just like this. So write clear, compile, and run. 6543, launch aborted. All right. So that's kind of the idea here. If I wanted to, suppose this were some other condition, like minus 3, so that there was a chance that it would pass this and never reach the abort, then it's going to print blast off. Well, I don't want to print blast off followed by launch aborted. Instead, what I want to do is go to somewhere around that, so below it. So we'll just throw in another go to after abort. Give that a semicolon, and then we'll need another line, another label after the abort with a colon. And just a clue there that for viewers at home that this actually works. All right, so colon, run this. So it's going to clear, compile, and run. And in this case, because I have this if I is equal to -3, we should get all the way to 0, reach the end of the loop, print blast off, and then never see that launch aborted. It should go straight to this line is after the abort. There we go. So 6543210, blast off. This line is after the abort. All right, guys, there's one more type of loop that I want to talk about. I've commented out all the stuff about just the generic for loop, and as powerful as it is, but I want to go into iterator-based for loops. So here, I just have a string. It's one of my favorite quotes from, it seems appropriate for a lot of the things we want to do in this class. It's hardware that makes a machine fast. It's software that makes a fast machine slow. It's by Craig Bruce. And I'm just going to print this out. In case you haven't seen this before, if you have a really long string, C++ will automatically concatenate adjacent strings, even if they're on different lines, and it doesn't matter how much white space is between them. So this is all one statement, beginning with the word string, ending in a semicolon. So that's a really great way to do this. Let me just demo that this works. So we'll go up here, we'll run it. So there's my quote. All in one line, it just concatenates things together if they're adjacent pieces of text. And next what I want to do is go back and use the iterator-based for loop. So for, in this case, it still needs parentheses, but I'm going to use, I'm going to declare a variable of the type that composes this sequence. In this case, it's a string of characters, so I need a char. I'm just going to label this C from, and then I need the name of wherever this is coming from. So we'll see the same iterator style loop for a lot of the built-in C++ structures like vectors and arrays and maps and queues and stacks, things like that, lists. They will all have this sort of structure available to iterate through and do whatever we want with. So in this case, let's just print out the character, each on its own line. There we go. That should be pretty straightforward. Let me make sure I didn't make any typos. So we'll write it and then run this. There we go. So now it's printed out all of the text, one character on its own line. Now, something to note real quick. I'm just going to make a copy of this. Copy and paste. There we go. This version makes a copy of the character from the string. So that means once we made a copy, we can't change the original string doing something like this. If I want to change the string, then I need to add an ampersand right here. Missed. Right there. So this will actually refer to the exact memory address. So it's going to go through. This C will now be that I in the string. And then it will be that T. So let's go ahead and instead of printing out this string right here, let's go ahead and say if C is exactly equal to, how about capital I, Then what we'll do is say that C is equal to, how about capital X? I don't think that should be too dangerous. And we'll see what happens. And then after doing all that work, we will print out the string again. This line right here. That was the wrong button. There we go. Just that much. We'll run this. Oops, have a bit of a typo here. So this is a string. I think what I really need is the character version with the single quotes. It's kind of a cryptic message if that's really what I messed up. Yep, there we go. So that was it. I'm going to go back, put that back, and take a look at that error message for you guys. So anyway, it's now replaced all the capital I's with X's. There's one right there, and there's one right there, both in the word it's. It's hardware that makes a machine fast. And just to show you that without this ampersand right there, if I take that out, write this, and run it again, that didn't do anything. It's because it now made a copy, and we changed the copy, not the original string. So this one makes the copy. This one actually changes the string. It's referring to the letters in this string. And one other thing while I'm here, if you're using C++ 11 or greater, you can use the keyword auto, and then you don't even need to know what the type of these pieces of data are. All I know is quote has a data that I can iterate through. It's a list or an array or something like that. Auto will automatically figure out what kind of data is making this up and automatically assign the correct type to this. So I'm going to write this, and then we'll run it. On the CSL machines, the compiler here is already set up to use the C++ 11 standard. If you run into any trouble, if you get a compiler error from this, one of the things you can do is you just need to tell C++ that you're using this C++ 11 standard with a new feature like auto. So to do that, the command is std equals C++ 11. So you just need to add this compiler flag right after the warnings. Anywhere in here actually. It'll recognize this dash telling it it's setting a compiler flag. So if you see any of those problems with that, go ahead and add that in. All right, I do want to see that warning message one more time. So, quote, what did I type wrong? Oh, lowercase c. Good thing it told me that. Let me go fix that. All right, here's that cryptic error message again. Invalid conversion from const char star. This is another word for string. We'll be learning about pointers coming up in 1 or 2 lectures. I think lecture 5, yeah, that's 2 from now. So a pointer to a character is basically an array, and it's trying to assign a single character. So that's why this string, the const char star, did not work. All right, guys, I can't tell how much time I've got left. I'm going to just take like 4 or 5 minutes and go over some of the really common I/O manipulators that you may want to use for the next 2 homework assignments. So an I/O manipulator is something that we give to cout. So cout is think of it as like a machine that takes in text and spits it out to the screen. It can also take in what are known as manipulators and use those to change how the numbers or letters look, how the text looks. So just as an example, suppose I'm just printing out 1.0. I'm just going to write this, run this. I get 1. It actually takes away the decimal point and the 0 if it rounds to the nearest integer. So if I want to bring that back, I can type show point. And this is an I/O manipulator that's going to just, here, let me just show you. Goes ahead and puts it in decimal place and shows it as a floating point number. So in this case, it's giving us 1, 2, 3, 4, 5 significant figures, or 5 zeros past the decimal place. In a moment, I'll show you how to manipulate that. Now, while I'm here talking about floating point numbers, let's also take a look at COUT, show pos. This will add the plus sign for positive numbers, so I can say 1.0 end line. And now that will put in the plus right there. Enter to continue. if I have numbers in hexadecimal that I wish to print, or if I wish to convert a number to hex, I can type in hex, and then I can give it some numbers. Just like that. There's right, and run and print. And it's going to take those and convert those into hexadecimal. So 1, 2, 3, 4, 5, 6 is 30, 39. Oops, 1, 2, 3, 4, 5 is 30, 39. I've got another option here too. Because it doesn't actually put in the 0x to indicate that these are hexadecimal numbers, I can go ahead and add in the show base. And then that will change the way these numbers look. And it will actually go back and add in the 0x in front of both of those. If I wish to switch back to decimal, suppose we want to do that right here. It's just DEC. And now the first number will be in hex, and the second number, 4, 5, 6, 7, will be in decimal. Also, C++ will let me put in numbers in hexadecimal. So in this case, I'm using 1, 2, 3, 4, 5. I'm going to print it out as hex. And I'm also sticking another hex number here, and I will print it out as a decimal number. So 4, 5, 6, 7. Let's just go ahead and run this. So we do get the 1, 2, 3, 4, 5 in hex. And then that 4, 5, 6, 7 has been converted to decimal here. So next up, I want to point out that a lot of these things work like switches. Once I have sent them into cout, they remain turned on. So like here, I turned on the show pause right there to get the +1. And from then on, every decimal number, I'm getting that plus sign. There's also a turn it off button for all these things. I'm just going to go ahead and add that right here. So I'm going to send no show pause right into cout. And all of these, the switch ones, either have a no, or they're just like show pause. Show point, there's a no show point, for example. Show base, there's a no show base to turn that back off. So once I do this, when I put the no show pause in, check it out, the plus sign went away in front of all of these decimal numbers, the 4, 5, 6, 7 and the 1, 7, 7, 6, 7 in those bottom two lines. It's gone. All right, another tool we have at our disposal is the ability to switch between fixed numbers and scientific numbers. So I can give this fixed, and then I can type in 1, 2, 3, 4.56789 end line. And I'm going to go ahead and just do the scientific notation one right here too. I believe it's scientific. I might have that spelled wrong. We'll run this. And then the fixed notation will just print it out exactly like this with the decimal place, and scientific notation will convert it into scientific notation. All right, next up, how to create fields of a certain width. So right now this number takes up like 10 positions. So COUT. The command here is set precision. And this could take a number of decimal places. Let's give it 2. And then we will do 1, 2, 3, 4, 5, 6, 7, 8, 9, end line, right, and run. And now we can see that it's printing out with exactly 2 decimal places. All right, I'm going to go ahead and run this same thing again, but I'm going to grab the fixed line. So we've switched back to fixed, and it's still giving me 2 decimal places. So that precision, set precision, tells me how many digits after the decimal place am I to print. Then there are a number of useful functions or IO manipulators for creating things like specific width boxes, which are great for making tables. So as an example of this, I'm just going to throw in some stars, something else, and some stars. So these stars will be my little brackets around my box that I'm creating. To create a little box with a certain width, it's set W. And then I can give this box like 8 characters of width. And then right now it's going to print 3 dots in it. I'm going to just take those out for right now. We'll put something back there in a second. I just want to show that this does create that little box when you don't screw it up. Oh, missing a quotation mark. Right here. Right, run. There we go. So it's now reserved 8 spaces, 3, 4, 5, 6, 7, 8 between those stars. All right, so next I'm going to go ahead and put in something in this little box right here. Let's go with A, B, C, D. Let's call that good. That should fill up half the box. So we'll write that. We'll run this. We can see that we've reserved, and it's got 4 spaces there. It's written 4 things in the box. I believe somewhere earlier in my code I have a right. I just have a feeling I was using that when I was creating my multiplication table. But we have a right and a left. So we can also put in the, let's see, that was printing on the right side, so we can change it to left. And then we'll just verify for ourselves that it does remain on the left, even on the next line down. Then we'll switch this to right. So right. So here's what it's going to do. It's going to print out A, B, C, D. It started on the right side last time I ran this. It's probably going to be on the right side. We'll switch it to left in that same box with 8 width. Left should be retained. See how it should remember that. So when I print it again in a box with a width of 8, it should be on the left side. I've got that in there twice for some reason. We'll just do it once. And then we'll do it and switch it back to the right-hand side. All right, so we'll do that. There we go. So right-hand side where it starts, left-hand side, back to the right-hand side. Okay, so right and left, we'll move it around. All right, the last one I want to talk about is the set fill here. Actually, I'm just going to copy this line right here and print that out. Right now, this is going to be using the right mode, so it's going to print ABCD on the right. I'm going to add one more little detail right here, and that's set fill. And now this will take a character, and I can put in, let's do the %, and then, yep, overwrote the letters there. So when I do this, it'll take, instead of filling in spaces during that little box where I had 4 spaces left over, it will put in, I got a typo somewhere. Hold on, let me see what I did wrong. Oops, I'm missing a parenthesis. So right here, need one of those. There we go. So now those 4 blank spaces right here have been filled in with the %. So the set fill lets me go ahead and replace the spaces with whatever I choose. All right, there's a bunch more. There's a reading on the linked on Canvas that you guys are welcome to take a look at. It's just a short summary. In fact, let me just grab this. This is what I've been using as I went through. All of these, oh, I want to do that one. Let me do that one first. Hold on, time out. Not ready. I like this one. So at the very beginning of this lecture, one of the things I did was print out true and false. So true, and then false. Let me do this just one more time. There we see we've got a 1 and a 0, because internally C++ represents all of these as numbers. They're just bits in the memory. Okay, so what I can do now, bool is going to take Boolean values and print them out using their alphabet characters. So I'll just turn this mode on. I can write that, we can run it, and now it's actually going to print true and false. I really enjoy this one. I use it a lot. I should have introduced this at the very beginning. All right, next year's class will be better. All right. Anyway, the IO manipulators has just it's just a list of all of them. You guys can click on them, open up in a new window, see an example of how they're used. All of these are the switches, so there's a no bool alpha. You can turn that back off. All of them are here. I skipped over printing an octal. I rarely use that. Actually, I don't think I've ever used that. Deceptive one here, the uppercase, I believe is actually for the hexadecimal, the 0x, and then the A, B, C, D, E, F that are in hexadecimal characters. It doesn't actually change text to uppercase if it's a string or something like that. And I talked about some of these, the output manipulators last time. Endline inserts the new line and flushes the buffer. Flush will just flush the buffer. That causes it to be printed immediately and not wait until the operating system is good and ready to take care of that for us. So I think that's about going to do it for me today. Let me go see how long this video is, and if I'm completely wrong and it's short, I'll put some more stuff in. If not, have a great day, everybody.